All right. So, Abby, I know that you are going to be working on some geometry, and that it was, giving us a little run for the money there. So, I am going to make you some videos going over all the units in geometry that you're going to be covering. So, I found for Virginia Beach Public Schools, all of the learning objectives that you're going to cover in that class. And towards the end there, that's when we were talking about those things like the arc length and whatnot. So I just wanted to show you really quick, I'm going to make you some videos about, so that way hopefully it can help you. And then from there, maybe if you have questions, you can ask specifically, once we make those videos for these different units. But so like you've got your unit 1 that's talking about reasoning and proof, and it's just pretty much, showing why things are the way that they are. Like, for example, this right here, like if you have a, triangle or some sort of parallelogram that doesn't exactly have, a unit written on it, how can you prove that something is the way that it is? Like, this looks like a good example. Like, it tells you that TAL is isosceles, which we'll talk about on those videos. But then how can you prove that something else is, true? So that's, what you're doing a lot of the time is like they'll give you one thing here. Like, okay, so here they gave you this. They said AD was something. And they said that BC was something. And they said, how can you prove that such and such is equal to such and such? So that's kind of what we're going to be doing there in Unit 1. And then Unit 2 is just, it says Foundations of Geometry. So, I mean, that one's going to go really quickly, talking about, just what the different things are, in geometry here, like, lines, segments, and rays and angles here, where you've got, of course, it's so small. Oh, my. All right, get in there. Line segments, rays, parallel lines, perpendicular lines, intersecting lines, right angles, acute angle, obtuse angle, straight angle, and all of these here, obviously, this is like a lower grade thing, where you're matching them up, and, but you still are going to be going over those foundations again in geometry, but oftentimes it'll maybe be on a graph, where you're seeing something graphed, and looking at it in that way, or, looking at it on a shape, seeing those parallel lines, like on a, pick one, I don't know, trapezoid, not a trapezoid, I don't know, a rectangle, how your lines are running parallel, where you got this parallel line here, that they never cross, things like that. Those are all really important things in geometry that you need to know. So it's funny when you pull it up, if you Google it, that you can end up coming up with a grade 3 geometry worksheet. But I mean, you really do go back to those grade 3 concepts, which is why I love math so much, because you just keep on pulling from what you've learned over the years. But anyway, and then I see over here, there was some more like, where was it? Like this one here. This one looks a little bit more difficult here, where it's telling you, are these intersecting? Are they perpendicular? Are they parallel? Things like that. So that's what you're going to be discussing there in the foundations of geometry there, and then taking it further and further and solving problems. Kind of like that one in that proof example, where it shows you here, look, we've got some parallel lines here, but these ones here, if they just kept on rolling on this shape and were infinite, that would they end up crossing? Would that end up being, intersecting? How would you word that? Things like that, okay? And then Unit 3, lines and their relationships. So in lines and relationships, that's still talking all about that parallel, perpendicular lines and things like that. You'll see it on, the graphs and the shapes. Unit 4, triangles and their relationships. Okay, that's one of my favorites because I love triangles. We're gonna talk about equilateral triangles, what makes a triangle obtuse, having a really, really big angle. What makes a triangle an equilateral triangle, how many angles are added up in that triangle. We'll go over all of that, and there's lots of theorems that explain those things. It says right here, I like this as triangle triangle sum theorem, exterior angle theorem. Those are really important things that we'll talk about. And then similarity. So, you know, that's almost like in fractions with lowest common denominator or reducing fractions and things like that. You know, it's kind of like that almost, you know, and we'll talk more about that, but you're going to be doing it with shapes, you know, like how can you prove that these shapes are similar? Like, what's the definition of that in geometry? And we have to be able to prove it, which is why in Unit 1, we're going to be talking about proofs, because you have to be able to back up your answer. You can't just say, oh yeah, it's similar. Why? Because there's going to be a reason why, because if there's not a reason why, then the two shapes aren't similar. And then Unit 6, right triangles, my favorite, the Pythagorean theorem. We'll talk all about that. That is my absolute favorite thing in the world. I can't wait to cover that with you. It's awesome. Polygons and quadrilaterals in Unit 7. I remember in geometry that was one of the toughest things. You know, we're going to be finding area and stuff like that. Like you've done that before with a square and a rectangle and stuff like that, but it gets a lot more complicated once we start using bigger shapes, and we've got to, you know, maybe break them up into pieces, or there's, you know, different formulas for different shapes, and we got to, you know, keep track of all of that. So we'll go over all those polygons and quadrilaterals that you're going to be covering. It says here, you know, you've got your parallelogram, rectangle, rhombus, square, trapezoid, kite, and you have to be able to identify what the shape is, because there's different formulas for those different shapes on how you're going to be able to get, you know, the area of those things. Unit 8, that's kind of where we were at, talking about circles and whatnot. We are going to be able to, you know, be talking about those chords and the major minor arc. We covered that a lot in that other video. That's awesome. But then talking about congruent arcs and congruent circles, concentric circles, and all that kind of stuff. And I'll be very curious to see, once we kind of like really go in there, like how far we're going to be going in, because I see here that we've got, what's it called? I lost it with my eyeballs. The tangent and cosecant and stuff like that. And, I'm very curious to see where that's going to take us, because that's going to be really fun. And then area and volume. That's kind of where I was talking about back here, you know, when we're talking about those different polygons and quadrilaterals. Once we get to area and volume, that's when we really are going to be paying attention, and it is a little bit difficult. But as long as you are doing those things like we were doing before with formulas, where you're really tracking your formula and, you know, bringing it down and copying and plugging things in as we go, that we'll be able to get where we need to go and accomplish it. And then that's where we're going to bring it back again to those similar figures. And that's kind of, again, like I said, about fractions, where it says, you know, that the student will calculate the ratio of the areas or volumes of similar figures. And it's almost like saying, you know, 1/2 is similar to 2/4. Kind of in that area, you know, and we'll talk about it more again, like I said. And then Unit 10, transformations. Now, those for me, that is definitely something that are, you know, challenging, because a lot of times that's on a graph. You know, they will graph you, you know, a shape, and then you're gonna have to figure out, you know, like, is it a reflection? Did they rotate it? Did they translate it? Did they, you know, what's it called? Rotate it on the line of symmetry. Like, it's, you know, most of the time it's on a graph, so we've got to be able to define all those things, and we'll be able to see it, and we'll break it down together. Okay, so, and then Unit 11, it just says advanced algebra concepts. Okay, and that's where I'm kind of excited, because that's when I was talking up here about, you know, sine, cosine, tangent, and, you know, all that kind of stuff, and the converses of those. But right here, I see law of sines and cosines, and that is super duper duper fun. You might not think so, but I'm gonna make it fun, and you're gonna be like, at the end, you're gonna be like, oh yeah, it is fun, because sines and cosines is super fun, and it goes right back into my favorite up here of the Pythagorean theorem. So I just want to let you know, I'm here for you. I'm super excited. I really want to help you get through this class, and hopefully maybe by the end, like, that you will be enjoying math and feel like you've mastered a lot of really difficult concepts, because math is, it can be challenging. But if you really look at it in that sense of going all the way back to like grade 3, that math just builds up on itself. It always does. Like when you get to calculus, you know, you'll be pulling back that stuff that you learned about the Pythagorean theorem, and you'll be pulling back that stuff that you learned from geometry and in things that you learned even in 2nd grade. You know, and that's why math is so exciting to me. And I know that you're going to be able to kick this class's butt. And I'm really excited to go over it with you and do these units. So what I'll do is I will post a video for, you know, each one of these units. Hopefully, maybe you can send me a couple of examples as we go through, and then I can probably find some myself too to be able to use to show you, you know, and really break it down, because it seemed like that was really successful for you when you saw things really broken down and why they were the way that they were, instead of, you know, just kind of giving a formula and then leaving you, you know, this is what it is. So I'll do my best to be able to try and break it down the best that I can and explain it, so that way we can understand why. Because I think when people understand why math is the way that it is, that it becomes a lot more fun and a lot more interesting. So just wanted to encourage you and kind of look at this and show you and break it down, and just really wanted to pull up like these examples just so that you can see how, even though it seems intimidating sometimes, that we look at it and we're like, wow, that says grade 3 or that said K5. Like, we can do this. We can accomplish this because you've done it before. Alrighty, so I think that we're going to be able to accomplish this together, and I will talk to you very soon.